Alright, so today we are going to look at the Pytheas Control software. Um, this is the main script, program, whatever you want to call it, that runs on the sensor platform itself and drives all of the data collection and live feeds up to the surface control unit. But before I get into that, I wanted to stop and kind of go back a little. I realized I never actually used the word Pytheas in my first video and never really explained what that is. Long story short, I'm just calling this entire little project the Pytheas project. That's not necessarily the name of the sensor pod, but just kind of the overall name for what I'm doing. And the reason I chose that name was because Pytheas was an ancient Greek explorer. Not too much is actually known about him. Not a lot of his records really survived, but there's an argument to be made that he was one of the first explorers from the Mediterranean to visit kind of the northern European area, and kind of discovered like the Arctic Circle and things of that nature. So I thought that was kind of a neat tie-in. Plus, the whole system is driven by a Raspberry Pi, so I thought, Pytheas. I don't know. I'm terrible at puns. But yeah, that's kind of the explanation for the name. And with that being said, we will go ahead, get back on track, and take a look at the software. So before we dive directly into the software, I wanted to kind of start at the Pi's terminal screen, just to kind of explain my method of operation, or at least how I think it's going to go. I am connected over an SSH connection, and that's how I intend to do it when I'm out on the water. I'm going to have the surface control unit just SSH into the sensor pod and control it from there. As you can see on the screen, the software itself is just a Python script, pcs.py. Python's just what I'm comfortable with. It's the language I know best. It's easy to work with. It works very well in a Linux environment, especially on Raspberry Pi. That being said, I think at some point I am going to have just a bash script as kind of a wrapper to help kick the control software off and start the audio feed in the background, things like that. But the real meat of the software is that pcs.py Python script. And as you can see, it is Python 3. I don't foresee there being too much of an issue running it on Python 2, but again, that's just what I'm used to. So with that being said, we can go ahead and actually run the script and take a look at the control software. As you can see, it'll start by asking you the name of the session. This can be pretty much anything. Just as an example here, I can write fictional lake spot 1. Just, whatever title you think is descriptive, do that. And then once you hit enter, it'll go ahead and initialize a session and bring you to the main control screen. Here you can see up at the top, you have the readout from the sensors, as well as the time that the sensors were actually pulled. Pressure and external temperature are both coming from that red dual-purpose sensor that you saw in the first episode. The depth reading is technically not a sensor reading, but it's computed off of the pressure reading, just using the standard equation for calculating pressure in a given volume of a fluid, which I'll probably pop up on the screen there for you. And then the internal temp is the temperature of the Raspberry Pi itself, like the internal CPU temperature. And the reason I have that is because I'm stuffing a lot of electronic components very close together in an airtight space. Um, and the enclosure is made out of acrylic, which isn't the greatest thermal conductor in the world. So there is a little bit of a concern about how the system's going to perform heat-wise. So I wanted to have that reading available to me so that I could quickly see if the system was overheating, and if I needed to, to intervene, shut the system down, whatever it takes to protect the components. Uh, so moving down, you see the address for the streaming video, which I'll show you in a minute. Right now, that's just a dummy IP address. That's not even the internal IP that it's running on right now. But at a later stage, when this is closer to complete, I'll replace that with the actual real address. It's mostly just a reminder anyway. I mean, the way I plan to have the Surface controller built out, I'm just going to have that address pre-programmed in the Surface control anyway. But I thought it'd be a handy reminder. ACAP is currently inactive. ACAP is just kind of my shorthand for autonomous capture mode, which basically it just, like I explained in the first episode, the system will just take readings at a set programmed interval, take pictures at a set programmed interval, and record all that data to the session directory, so that in theory, everything's getting recorded in a CSV file, so it should be easy to just import those readings into Excel or into an analysis program, just, whatever you need it for, whatever is best for working with the data. So when that autonomous mode is active, it's going to be active in a separate thread, so I just have this little warning, or not a warning, more of a reminder. I have a little reminder up to tell you when an autonomous capture is happening in the background and when it's not. So, there we go. And then underneath is kind of the menu options, which I can go over now. So, the menu is pretty straightforward, and probably doesn't contain too many surprises. Capture picture just instructs the camera to take a picture. Pretty straightforward. It'll save it with an automatic time-stamped file name, which you can see happening right now. Pretty straightforward. Automatic data capture is, like I said before, it's how to set up that autonomous capturing of sensor data. You can set the values you want, like we can just say take a reading every 1 second. Backups, that's actually pretty important, because it's kind of a dangerous environment for electronics, and a leak could happen and destroy the entire system. I wanted to have an automated backup feature. My idea being that the Surface Control Unit can just expose an NFS share, which for those of you in Windows land, NFS is kind of the Linux equivalent of a file share. It basically just lets the Pi mount that share as a local drive, so that the backup file can be saved to it. And then in reality, it's not being saved to a local directory, it's actually being saved to the system that's exposing it, so the Surface Control Unit. And all of that is a very lengthy and nerdy way of saying it will copy the data at a set interval to the surface on the boat, so that even if the system, springs a leak and drowns, I'll at least have a partial copy of the data up at the surface with me. So by default, that happens every 50 ticks, or I can hit 0 if I don't want it to happen at all. We'll just leave it at the default for now. Then you can specify how often you want a capture, an image capture to happen. Let's just say every 30 seconds, or again, if you hit 0, it'll be off. And then how long do we want this to go for? How many captures do we want to, well, capture? We'll just say 60. So at an interval of 1 per second, that'll end up being 60 seconds or a minute. So once we enter all that data and hit go, you can see now it says ACAP is currently active. It is taking those readings in the background and just logging them all in the CSV file for us. And I think I'll actually fast forward a minute so that we can back out of the program and I can actually show you what it's, kind of what it's recording. So we will stop here. Alright, so we've waited a minute, the autonomous capture is over. I've gone ahead and exited the control system just so I can kind of show you what happened under the hood and how this works. So we're back at the terminal. I'm just going to go ahead and list the contents of our directory again. So you can see there's been a few things that's been added since we ran the program. First, you see that aux underscore fictional lake, blah, 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 blah. That is that backup file that I mentioned earlier. Like I said, the intention is for that file to go to an NFS share so that it's copied up to the surface. But right now, while I'm in a testing environment and don't actually have the Surface machine ready yet, I just have it copying locally because it's just dummy test data right now anyway. But you can see it's a CSV file. It's basically just an exact copy of the CSV that it was recording all along. So I'm not going to bother checking out its contents right now because it'll be pretty much identical to the main file's contents. But moving on, you see that directory, fictional lake underscore spot 1. That is our session directory that we created when we first started the program. And if we want to look at the contents of that directory, it's basically just all the data from that session. At the top, you see the CSV file where the autonomous capture was, and you can tell that because it says ACAP in the name right after the session. Underneath, you'll see 3 pictures. Those are all the pictures that were created during the session. The 2 autos were made during ACAP. If you'll remember, we set it up to take a picture every 30 seconds. So it had time to take 2 pictures during the 60-second run. And then the one at the bottom that says manual, that's when I hit that menu option 1 and just took a manual capture. So if we import those to a computer, we'd actually see the camera images. And I'll try to show them up on screen, but you'll see that sorry, my recording looked a little weird there for a second. If we import those to a computer, we can look at those images and see what the camera actually saw. And you'll notice that the sensor data is embedded as text up at the top, just for easy reference. And then at the bottom, we see another CSV file. That's what I'm calling the passive capture. Basically, that's just a file to dump. How to explain this? The system has to check the sensors occasionally just in the course of running. Even if it's not in autonomous capture mode, it still needs to capture that sensor data just to do things for like refreshing the screen, things like that. That data gets recorded into that passive log there. And again, it's just a little more redundancy, plus any handwritten notes, which I'll show you that feature in a second. Those will get recorded to the passive log. But yeah, that's pretty much what it looks like in there. And we'll go into more depth about some of this later. But there's one more file I wanted to show you. If you look in the root directory, you'll see a file, pcs.log. That's just the log file for the PCS software itself. Right now, I have it running in debug mode, so there's a lot of extra data. But basically, it just logs exactly what the program is doing, shows when sessions were started, when pictures were taken, when ACAPs were taken, just all that fun stuff. Whether or not certain threads shut down cleanly, things like that. So if you ever run the software yourself and it's acting weird, you can always come to this log and hopefully that'll help you out. And speaking of which, I do intend to publish this software as open source once it's in a respectably complete state. So it will be available to download off GitHub in case anyone ever wants to replicate this or modify this or what have you. So to kind of show you what these CSVs look like, we can, we can just go ahead and take a look at that ACAP that we captured and prepare for text spam. Yeah, it pretty much looks like this. So again, it's just a raw dump of the sensor data once per second like we prescribed. There's a T value, which just tells you which tick we're on. L time, that's local time, is just whatever the system clock says the time was at the time the sensors were read. Pressure, depth, external temperature, I've already explained those, as well as internal temperature. So yeah, it looks a little rough in this state, but again, you can take this file, import it into Excel, generate graphs, run it through analysis software, just whatever you want to do with that raw data. Alright, so we're back at the main page for the PCS system now, and we're going to go over some of the other menu features. The next one on the list is changing the camera settings. So for that, I thought I would take this opportunity to pull up the actual live video feed. That'll make the changes a little more obvious. As you can see, it's just a raw H.264 stream, so you can just pull up really any media player. I use VLC, but any media player, just pull up a network feed, enter the address, and there you go. There's your live feed. See, wave my hand there. As you can see, the sensor readings are reported up at the top there, so you have kind of an easy live view. So we'll just have that up while I go ahead and show you the camera settings. It's just another menu. Nothing too crazy going on. Adjust brightness, contrast, exposure mode, and light balance. Those are presets that were built into the camera module's Python libraries. They're not really ones I made myself, but it gives you a little extra flexibility to switch these presets. I'm hoping that'll help me if we run into like a low light condition or anything like that. You know, just nothing crazy, but you know, see, we can pump up the brightness, stuff like that. And then 9 if I just want to quickly reset everything to defaults. The fifth menu option, use lamp during capture. We went over it in the first episode. There is going to be an LED light bulb as part of the system, which the Pi will have active control over. So that that menu option number 5 is basically just, do you want to have the light on when a picture is taken? Basically, do you want the flash on, more or less. So that's, I mentioned in the first episode, I'm not even sure how well that light is going to work, but it's going to be an interesting thing to test. So moving on, the next menu option is writing a note to the log. The log it's referring to is just that passive CSV capture file that we saw earlier. And it's basically just an option to write a free-form note. So let's say we saw something interesting pop up on the video feed. You know, big giant hand shows up. I can make a quick note. You know, saw a big giant hand, and now that got recorded in the log. So when I go and look at that log, I'll be able to see that note and see the time it was taken, see what the sensors were saying at the time it was taken, all that good stuff. And that'll help me sync up, you know, like if I need to find a certain picture or see a certain, you know, check a certain event in ACAP, I can refer to those notes, and that'll help me kind of pinpoint what's going on. And then the last option, toggle lamp, again, that's just a manual control for that LED light bulb. I'm not sure how well you can see it on the screen, but yeah, it just turns that LED light bulb on and off, just kind of for ease of use. And then those options down at the bottom, refresh display, that just refreshes up at the top there, that title bar. So I can see, you know, get a quick read on what the sensors are seeing if I don't have the video feed open. And then quit. I hope I don't have to explain quit. But yeah, so that's basically it. That was probably a clear as mud explanation, but that's the current state of the software. So with that, next episode will probably be about actually testing the system out in actual water. So, till then.